Okay, let's continue. Okay, before the break, we cover these three equations to calculate the energy of the emission. All right, C equal to F lambda, and then we introduce you E equal to F H Planck constant, and then we combine the two equations, become E equal to C divided by lambda multiplied by H. Right? C is a constant value, H is a constant value where we expect you to memorize, like gravity value. Okay, now we go into the atomic theory. Bose model, we look at hydrogen atom first. So we start with the very simple atomic models, which is H equal H1. We have proton and neutron at the center. And then we have orbit number 1, orbit number 2, orbit number 3, and so on. So when there is an energy absorbed, so at stable form, you have one hydrogen. Hydrogen, when you have a stable form, you know that hydrogen H1, so you have proton and then one electron. Okay, electron, we have proton, electron. So this is n equal 1. We start to look into the orbit. So when you give energy or energy absorbed, you give energy. So when you give energy, proton cannot do anything. It just stay at their position. But when you give energy, the thing that can move is the electron. Electron will jump to higher order of orbit. It jump from N1 to N2. Okay, it's like a highway. N1, N2, N3, they are highway. So if you take away energy, minus E, the electron will jump back to from N2 back to N1. Okay. Now the higher N number, which means it's like a highway in Malaysia. If you want to speed, you go to the far right. You go to the far right, you want to speed up, so you go to far right. So it's the same. So if you add energy or absorb energy, means you press on the pedal. You press on the pedal, your car will speed up. So when you speed up, you move to the far right of the lane. You move out to the right. So it means you move out. And then when you let go the pedal, the less energy, your car slow down, it will move inside. Okay. So this is another one. So when the symbol used for absorb means energy, and then energy emitted, then it will come back, means it release energy. Okay, when release energy, electromagnetic wave will transmit and so on. Okay, so this is in the energy dimension. Energy dimension. So you have positive E and negative E. Positive means you add something inside, you press on the pedal. Minus means you release your pedal and then you move back to the lower energy orbit. Okay. So for all atoms, the lowest energy states is at n equal 1. The lowest energy states. For example, hydrogen is the lowest energy there. They call it ground state. Ground state. Rest you read. Okay. Rest you read. The energy that the magnitude of energy, it must be the same for the electron to jump outside or jump back to the location. The energy must be the same. Okay, so that is the concept that we have to remind ourselves. So another was the energy released, energy emitted or released in the form of electromagnetic radiation. So this is, you need to refer back to the chart just now. You see before the break. So this is the radiation, like what is the frequency that emitted from there. Okay, so it's called protons. A proton and a specific wavelength and frequency. Okay. Now, how do you link the equation that you learned just now and with the chart? Okay. Later in our tutorial question, we'll give you the sample, how you apply what you learned. Okay. Now, we go deep into the orbit already. Now we dissect the highway. Inside highway, you have a different lane. Highway number 1, highway number 2, highway number 3, and highway number 4. So inside highway, you have a different lane. So for example, maybe this might be a bit complex for you, but what is important here is that the n number. N number means the lowest orbit. N number 2, second highway. N number 3 is third highway. Okay. So again, we quantify or the magnitude of the energy needed for the electron to jump from one highway to another highway. N1 to N2, N2 to N3 is specific. There's a magnitude already. So later in the test, you will see one chart, something like that. On the left-hand side or y-axis, you will see energy. Bracket EV is energy, electron voltage, or the changes of potential energy. Voltage is the potential energy, right? Like what you learned in your E&E class, right? So to jump from here to here, this is the energy it need to jump from 1 to 2, for example. Okay, so this is the position just position negative. But if you increase more, become more and more positive, then here is 0. Then -5 and so on. Here is 0. So negative, it means energy that you need. So you take this magnitude minus this magnitude, you get the differences. This is the energy needed to jump from n equal 1 to 2. Same magnitude to jump from 2 to 1. Okay, it's not directly read from the y-axis. You need to take the differences between the two positions. That is the concept. Okay. So the rest you read. Okay. Now, once you understand lane number 1, lane number 2, highway number 1, highway number 2, highway number 3. Later, you will look in various specific highway. So this is a ground state. Ground state means either at a stable state, ground state. So for hydrogen, the value is -13.6. Then if you want to, and ground state at level 1 also mean Lyman orbit. Lyman orbit. So for example, then the second highway is called Bowman Highway, or n equal 2, Pasture, bracket, and so on. So each highway have their own name. Like in Malaysia, you have Lekas Highway, and so on. Okay, Smart Tunnels Highway, and so on. So it's the same. But in the molecular dimension, you have Lyman, Bowman, Pasture, bracket, and so on. Okay, right. And the energy is increasing as you move up. As you move up and up to infinity. Up to infinity, and so on. Okay, so there is a Bohr's model equation to calculate the energy. Just now you have the E equal to FH, right? Or C equal to F lambda. So now there's another equation after the break. Your energy can be quantified by this equation, 2 pi square me power 4 n square h square. So what does it means? But just to summarize, you just use a constant value 13.6 n square. Okay, n square also is a negative. There's a negative number there. So if you substitute the mass, you multiply the pi 3.142 something. H is the Planck number. So you take this one, and then the E just now also have like one E had got how many column of energy. So you take all this number, you sum together, you get one constant number, 13.6. Okay, so 1 EV equal to 1.6. So you substitute this one here. M is the mass of that hydrogen, is 1. 2 pi is 2 multiplied by 3.14 multiplied 2. You divide it by Planck number, you get 13.6. Okay. So there's another constant number that you need to memorize. It is 1 EV equal to 1.6 10 power negative 19 joule. Okay, this is a constant value you have to memorize, right? So there are few constant value for chapter 2. Okay, so one is 1 EV got how many? E, you don't need to memorize the equation, this one. Straight away memorize 13.6 divided by n square. Okay, and so on. Okay. Okay, the rest you read. There's a negative sign here. There's a negative sign here. So one terms, when you look at Bohr's numbers, is the minimum energy required to move the electron from one highway to another highway. It's called ionization energy. Okay, means you need to supply the energy, which is E equal to 13.6 divided by n square. N is a number, the highway number. If at ground state means n equal 1. If it's at Balmer Highway or N2 at Balmer Highway or N2, so you substitute n equal to 2 in that equation, 13.6 divided by n square. So if you take 13.6 divided by 2, if it's ground state, your n is 1, so you get minus 13.6 EV. Make sense? If you take this number, minus 13.6 n square. If it's ground state, n equal 1, so you get 13.6 for hydrogen. Okay, so this number 13.6 is for hydrogen. If it's other element, you need to recall this equation again. So don't like use 13.6 for other, for carbon is another number. Right? So this is for hydrogen, 13.6 for hydrogen. So it just explain the number you see on the screen there. Right? There's a way to calculate 3.4 minus 1.5 and so on. Okay, by the equation there, by this equation. Okay. Yeah, the rest is just explanation for how you get the number. Okay, so what is important is if you get if you get E equal to positive, the energy is absorbed. Means the change of energy is positive, energy is absorbed. If the energy is negative, energy is released. So energy is absorbed. What does it mean? It means electron can jump from one state to another state. It absorb energy, then it can jump. So when it jump, your value is positive. Why? How you get positive? How you get differences of numbers? How you get delta something? You get n number divided by beginning number, right? Correct. Yes. So for example, if the energy absorbed from Lehman to Bowman, if the energy jump from here to here, the electron jump from ground state to bomber, you need to give them energy, right? So energy absorbed. So the N minus 3.4 minus 13.6, you get positive value. Make sense, huh? Minus, because the magnitude here is negative. Yeah. So if energy release, if the electron jump from 2 to 1, means you need to release energy. So what you take minus 13.6 minus 3.4. You still get negative value. That's why when you have changes of negative, it means energy release. Energy release means it's go back to lower highway or lower N number. This statement is important. This one, you need this to answer section C kind of question in the test one or in your final exam. Okay, it will ask you to explain how you know, or it tell you explain the movement of electron based on your calculation in section B. Right, so you need to apply the equation of E, the frequency there, and then you calculate whether it's negative something at a certain level. Then it tell you, okay, if a certain energy was given or was supplied to the element, what happened to the electron? Will the electron jump from Bowman to Paschen or from Bowman to Lehman? You predict the electron movement based on the number you calculate. So that is the different way, different kind of answering question compared to the secondary school. Secondary school, you don't see something like this. Okay, and try to think like how we ask you question. Are you able to solve that kind of question? Okay, okay, important. This one is important. Also, I give you the important calculation. All right. Now, another equation, if you apply this 13.6 for hydrogen, you'll get 1 over n final square minus 1 over initial square. Okay, so it just tell you that, okay, if you want to predict from where to where, so you just substitute the number here for hydrogen. For hydrogen, but for other element, you need to calculate the constant value based on this 2 pi square m e power 4 divided by n square h square. Again, 13.6 is for hydrogen only. Okay, so the rest I just show you how to calculate. So the changes for to jump from N2 to N1 means from here to here. It drop from here to here means it release energy. So release energy, you will get minus 10.2 eV. Okay, it's not the number, it's the differences, the potential energy is different. Okay. So again, I want to highlight these two statements. It's important to explain your answer. Why you say that is receiving energy or is jumping from one to another one. Okay, it's deal with the energy either absorbed or released based on your calculation, based on the changes of energy. Okay, so you see this one is released lah. Let me see. So it should be positive. Okay, suppose. Yeah, the value should be positive, right? Negative. 1 minus negative. Okay. To determine the wavelength, you recall the equation just now, E equal to C lambda H. So if the question asks you to find the wavelength with the application of the chart, so you just rearrange the equation, put the lambda to the left, then you substitute the value that you know. So lambda equal to CC is the standard value, 3 × 10⁻⁸ meter per second. E is the energy that you calculate just now. So is this is the magnitude. Important is use the magnitude 10.2. So you multiply by H Planck number, 6.63 10⁻⁻23 joule per second. So you cancel here and here, and then you have a joule. Then EV, this one is also joule. Volt divided by meter and joule is the same unit. You cancel out, you get a meter. So this one cancel, and then you get meter. So you have 112 nanometer. Nano is 10⁻⁹, -9. So you refer to the chart. Where is 120 nanometer? Where? So here maybe you don't see it. All right. Okay. You see the unit? This nanometer already. Although here don't have -9, but here already in the nanometer. So it's a bit tricky when it comes to this kind of question. So then say, hey, Doctor, I didn't see nanometer. So I mean, you don't see -9 here, but actually the scale is in nanometer already. So what you do, you go to 120. 120 is around here. So 10, 10⁻⁻1, 10⁻⁻1, 10⁻⁻2 is about here, 100 here. So this is 1000. So 100 is here, 1000 is here, so 120 is about here. So you go to the chart, you draw one line. Sometimes this module you need to detach the chart and then stapler together with your answer. So the question will ask you directly, give you instruction, use attachment what, and then detach it when you submit your answer. So you draw a line, you write lambda equal to 120 nanometer. Then you depends on what the question asks you. Okay, so it's towards the ultraviolet and after the visible line. Right. So this wavelength correspondent to ultraviolet range is about here. Right. So if you compare this value to a colorful chart, then it's within the ultraviolet range. Okay. So this is how you apply it. Right. Now example 3 is the application of what we learned so far from this morning until now. So it gives you a scenario, you give a hydrogen. Of course, again, 13.6 is a hydrogen. If the question changed to another atom, you need to calculate 2 pi square me power 4 divided by n square and so on. Okay. No, this you won't see formula given. Yeah, you will see table, you will see chart. Some table, some chart have equation inside. You need to be smart to see where is it. Some. But all these formula is you should memorize. But again, when it comes to test, yes. Of course, when it comes to test or final exam, I will tell you the scope. So when you know the scope, you know what you need to memorize. Okay. Right. So okay. So for example 3, atom have n equal 3 state. The electron undergo transition to n2. So it dropped from highway number 3 to number 2. So what happened? It absorb energy or emit energy? Release energy. So that is the thing. So you can answer the D already here. Okay, is the energy absorbed emitted? So this one, the answer for this one is emitted. But you need to support this one with numbers, with a statement. The two statement that are in red color just now. Okay, so you answer based on the calculation, not the like one statement then no no support answer like that. Okay. Now you need to calculate the energy responding to the proton, frequency, wavelength. Then this is based on your calculation. Which series does this belong to? This is the name of the highway. And what specific type of emission does it represent? So this one you refer to the chart like ultraviolet just now. Okay. So the first thing is application of this one. So before you start, you write n equals something, and then you write this statement. So this actually give you marks already. Okay. So delta E equal to final minus initial. So you need to calculate the energy. So energy final, energy equal to minus 13.6. Important is there is a minus sign for hydrogen. Minus 13.6 divided by n square. So you jump from 3 to 2. So the first one is 3 minus n initial is, final is 2, initial is 3. You substitute the answer there. Yes. Okay. So you substitute the value, you'll get minus something. Okay, make sense? Right. Now, once you get that one, this one sometimes it will be given in the question. So 1 EV equal to 1.6 10 power negative 9 joule. So you multiply accordingly. Right. So you multiply. So the change of energy will be minus 3 point something 10 power negative 9 joule. Okay. This actually, yeah. Okay. So you take out the EV. Right. Where? Is what you calculate just now. Just now you go out. It's the equation E equal to 2 square m e power 4 divided n square h. You know 2 pi 3.142 something. M is the mass of the hydrogen is 1. For periodic table, carbon is 12. Right. So H is Planck number. Planck number H. Just now you calculate this one. 6.63. This one, the energy one, the H. So you substitute there, you arrive at 13.6 something. So that's why there's a minus 13.6 here. Okay. So first question answer already. Next, you want to find the frequency, right? Apply this equation. E equal to FH. So just substitute the answer there. E equal to FH. You calculate the E already. Substitute here. H you know. H is 6.6 10 power negative 34. Put inside here. You get. Yeah, this one also we assume you know, like gravity value. Okay. Now, it depends. Sometimes if we give you, then no point, no marks for that lah. If we don't give you, then there's a marks for Planck number. Even you write this, you will get get marks. So the less information we give you means the more area we can give you marks, free marks. Just memorize and then put in there, you get marks. If we give you more information means less mark for equation, and then the question will be more harder. It will ask you to explain more things. So it depends. I will choose you to memorize the number. Okay. So at the end, you get one frequency, hertz, right? So 5.4 10 power 14 hertz. Wavelength. Here you have frequency. You have the C equal to F lambda. So just rearrange and then substitute. Press calculator. You get the lambda. Okay. So speed of light 3 10 power 8. Planck constant 6.6 10 power negative 34. Substitution, you get 659 nanometer, 10 power negative 9. Okay, so you have the frequency and lambda. So basically, by using frequency and lambda, you can go to the chart, and then you see what region is this, in either is a radio wave or is a X-ray kind of emission. So here, energy is released because the electron transfer from 3 to 2, right? So you just write this one, right? Energy is released, right? So what series? This one, it depends on question, and normally this one will be in the appendix or reference area. That you just flip to the last page and then you see this one. Of course, the numbers sometimes I will remove. But if I don't remove also, you need to know that this is for hydrogen. All these values for hydrogen. Don't just copy this one. Okay, important is the name of the highway. So in this case, it will emission belongs to Balmer's series. Okay, we jump from 3 to 2. Okay, 3 to 2 is Balmer's. So if for N3 to N2, so it arrive at Balmer's. Okay, so if you're at ground state when layman, so it stop at N3, then it's partial. Okay, it look at the final destination, what final destination of the electron. Okay, so it's red light. So if you go into the chart, so you have frequency, lambda, they're actually the same. So you go to the chart there. So it's about here. Okay, 659 is about here, red color. Okay. Okay, so this is how you do it. Okay, go a little bit more. So again, we take hydrogen as our introduction to electron structure of atoms. So this table is just tell you that this is probability of your probability means the chances of finding that element. Okay. Now this is the Bohr's model. You know this is proton and neutron and then the electron. So you see the green color statistics, probability statistics. So you can find most of the electron at a certain distance from the nucleus. Okay, so this is the probability. The highest peak is the highest probability, and this is the distance from the proton. Okay, there's a distance there. This is another side. This is another side of the chart. So this is only half after the chart. Okay. This is called wave mechanical model. Okay, and the rest you read The rest you read. This is also very theoretical. Okay, we start to look into lane of the highway already. Just now it's a very big number, n equal 1, n equal 2, n equal 3. Now we want to look into lane number 1. How many lane you have? Lane highway number 2, how many lane you have? And so on. There's equation to calculate how many lane for that particular highway. So we'll use a few symbol, N, L, ML, and MS. So the first one is called principal. We use N with the number that you see in the previous example. So if your principal number 1 means highway number 1, n equal 1, and so on. Okay, and sometimes we use principal energy level. Sometimes we use shell to represent n. Shell number 1, shell number 2, shell number 3, and so on. Why we use shell? Shell, the shape of the shell is like it's like an egg This is like a shell. So shell number 1, N1, N2, N3, and 4. Okay, so sometimes the question will use different name for N. It can be used shell, it can be used energy level, it can use number. Okay. Second one is a small small track or subtract. That one we call it subshell, which is highway. Within highway you see lane, right? So it's the thing L. Okay, the L number or the subsidiary quantum number or orbital number or subcell, cell and subcell. Subcell means you go inside there and then you see how many lane inside there. The third one, magnetic M, and M is a magnetic property of that electron. M. This is ML, means it look at subcell in a magnetic dimension. Okay, magnetic quantum number and orientation. The last one is MS. MS also in the quantum number, but this one referring to spin, the direction of spinning. This one, ML is the orientation, either like that, right? Spin is how they spin, the direction of spinning. Okay. So we slowly dissect the Bose model. Okay. So this one, for our first class in Mohs number, you see this number. But slowly, as you progress, you don't need this number anymore because there's a calculation for all these numbers. You just substitute accordingly, right? Now, for example, number one. Number one, sometimes we use K for number one, KLMN. Okay, K also means shell number one. Subcell is called S, number of state, and so on. You slowly go into the calculation for the numbers. So just now, you look at this hydrogen, ground state n equal 1, and n equal 2, 3, 4, and 5. So in this hydrogen, you are seeing a few principal numbers, or we call it energy numbers. So just now, example, you already see how to find the energy to jump from principal shell or shell. Okay. Okay. Now is another new things. You look into the lane of the highway. So we call it subsidiary orbital number or subshell. So different shell have different numbers of lane. So there is a calculation to calculate how many lane for each of the highway, right? So as this is the general view of how it looks like. For example, this is the ground states n equal 1, but become 2 already. 2 you have 2 lane. 3 you have more. 4 you have more, and then you start overlapping at outside. Okay, so we slowly explain how you get this projection. Okay. The important things is there's an equation for that. So L, there's an integer to represent this L number. There's an integer ranging from 0 to n minus 1. N is a principal orbit. For example, okay, for example, n equal 1, so there's only have one principal, no subcell. Okay. So if 2, n equal 2, n equal 2, you have what? You have n equal 2, 2 minus 1, you have 1. So you have ranging from 1, 0 to 1. Okay, and so on. And then you use letter to represent S, P, D, F. Okay, so means 0, if the letter is 0, then you use S. 1 is P, 2 is D, 3 is F, and so on. Okay. So this one you slowly digest. Basically, it break into the small lane inside the highway. For example, number 2, you have S and P. So basically, you have 0 and 1. Because the equation is 0 to n minus 1. So if n equal 2, so 2 minus 1 is you're ranging from 0 to 1. 0 to 1 is 0, 1. So what is 0? 0 is S. 1 is what? 1 is P. So let's say number 3 is number 3. 3 minus 1 is 2. So it's from 0 to 2. 0, 1, 2. So we have 3 numbers. So you have 0, 1, 2. You have S, P, and D. So when you draw the graphical presentation, you have 0, 1, and then 2. You have 3 number here. So you have 3 lane for highway number 3. You have S lane, P lane, and D lane, or 3 track if you want to. So you can present 0, 1, 2, 3. Or if you are, or in the exam, maybe you panic, you don't know the S, P, and D, you can just draw 2 and then you write 0 here, 1 here, 2 here also can. Okay, it just represent that you know the thing, but it's better you memorize S, P, D, F, and so on. Okay, so the subshell, the shape N is like a big shell. N is the orbit. Then L, they look like sphere. So if you have S means 0, for example, this one, it look like sphere. 2, it become bigger sphere, and third sphere, and so on. So you have from small sphere, bigger, bigger, bigger. Okay. Yeah. So it's like if you have one subcell, so one S, it means you have one sphere like that. Can you imagine? This is a proton. Then there's a sphere here. It's like that, like a ball here. Then the second ball, bigger, bigger, and then bigger, and so on. So you get seeing a sphere shape. Okay. So L1, L2, and L3, and so on. Okay. The sphere is increasing and increasing. Okay. So P, the first one is L or 0. It look like sphere. The second one, if we move to 1, just now you have this subcell, right? This subcell number, this one, 0 to n minus 1. If your this one is 0, it will look like sphere. If it's S, means sphere, right? But what happened, the shape of the 1 or P will look like this. This is L0. 0 means sphere. That's why we use S to represent sphere. When it become 1 or P subcells, we use dumbbell. It look like this one. Okay, so you look like this one, and this one. So there's a, if you combine X, Y, Z, you will get like 6 dimension. X, this is X-axis, so you have a like a figure of 8 along the X. Then Y is along the Y. Z is along the Z. Okay, so it's a dumbbell P. So you have 3 axes and then 3 possible location. Means the electron can move in X direction. It can be moved in Y direction. It can move in X direction, Z direction. So there are 3 possible escape route for the electron to spin around. Okay. D is a 0, 0, 1, 2 is a number 2. SPD is a D subcell. D, they are important for transition of metal ions. So if you have D, it looks something complex like this. Okay. If you have 0, 1, 0, 1, 2, you have more than 3 lane for that highway. The third lane is important for transition of metal ion. Means there's a chemical reaction already. So you'll move something like that, but you don't need to memorize this one as long as you've seen this one before. Okay. Now the first one, 0 is a sphere. Second one, 1 is what? The dumbbell, figure of 8. The third one is this one, SPD. Third one is like a 4 balloon on that dimension. Okay, 4 balloon, and then this one might be a bit complex and so on. Okay. Okay. The rest you read, huh? Again, the higher it go means the bigger balloon size you have. Okay. Then you look at ML, which is the magnetic numbers, orbital and orientation. So this one is have plus L and minus L. So for example, when L equals 0 or S, the responding is 0, means your L is 0. So 0, 0 is 0. So no positive and negative. So if your L is 1, L is 1 is plus 1 and minus 1, and so on. 2 means you have 5 numbers. Huh? When the L is 2, you have 5 numbers. You have plus 2 to minus 2, means you have minus 2, minus 1, 0, plus 1, plus 2. And so on. Means the larger your L number, the more magnetic number you have. Yeah. So for every subset of L, there is an equation 2L plus 1. So every subcell here, there is an equation 2L plus 1. So later we will give you the information. Okay, there's an equation 2L plus 1. This is to calculate subcell. Subshell this equation to calculate orbits. How many orbits you have? Orbitals you have. Okay, subcell, which is depends on the numbers. So just now, in the beginning, we learned about n, number of n. Then we go into subcell. Subcell, you have SPD. SPD. So inside the SPD, to calculate the orbital, how many orbital you have, you use this equation, 2L plus 1. So your S is 0. So if it's 0, then you only have one orbital. 0, 1, if your SP, if your number is P, then you have 3 orbitals. Okay, and so on. So you flip back 2L plus 1. So if it's 2L plus 1, you use this one to calculate orbital. If is n equal subcell, this subcell 0, 1, 2, subcell, the first one is L. It's not L. Not L. Okay, subcell is L. L is 0. So you put this one, 2, 0 means 0 plus 1. You only have one orbital. That's why you see sphere. Okay. Now what happens if you increase your L? Your subcell become 1 already. Your equation is 2, 1 plus 1. You have 3 orbital. For subcell number this SP, if your number is P, then you have 3 orbitals. That's why you'll see these 3 possible answer. Is 1 orbital, 2 orbital, 3 orbital. Okay, the way it moves might be not as conventional that you think, but there are 3 orbitals there. Okay. So it depends on the numbers here. So you substitute the L number. So L it become the 0, 1, 2, then it will become more lah. It become rich already. SPD, when it reach D, the number is 2, so it become 5. So that's why you see 5 different type of electron movement. So you have this 5 lah, but I don't expect you to memorize this diagram. But you have to memorize this equation, 2L plus 1, to calculate how many orbit you have. Okay. Okay. Now, a new equation to calculate number total orbital in the principal cell. Don't confuse with this equation. 2L plus 1 is to calculate subcell orbit. To calculate number of orbits in a big one. Let's say this is n equal 1. And n equal 2. In principal dimension, you want to calculate how many orbit in principal orbit. You use n squared to calculate how many orbit you have. How many orbit inside this one. For example, the first orbit, first n highway number 1, you only have 1 orbit. Principal number 2, you have 4 orbit inside there. Okay, means inside here you zoom in, you will see four lane there. And 3, then you have 9 orbit there. Or 9 lane, if you want to call it lane, but in your answer don't use lane. They are called orbits. Okay, now how to get 4, for example? Just now, n equal 2, you want to go inside there. So here, principal 2, this one, you calculate okay. So this one you will have SPD. Okay, this one later. Okay, then the last one, spin, either clockwise or anti-clockwise. The last one only have clockwise or anti-clockwise. Okay, positive or negative. Okay, so this table, it explain what we covered just now or for today. N is the principal, which is the highway number. L is a suborbital. L, you have 1 until negative n minus 1. Right? So just to summarize, by using this table, proton, neutron. So n is a principal number. So sub atom number is inside here. So you are using 0 to n minus 1. Okay. By using subquantum number, magnetic number, and so on. Okay. So let's look at this one. So for example, the principal quantum number n. So if you have only one orbit, you have s, for example. If you orbit number 2, you have p and s. You have 2 orbit. N equal 3, you have 1, 2, 3. Okay. 4, you have 1, 2, 3, 4. 5, you have 1, 2, 3, 4, and another one. Okay. 6 and so on. So you have more and more like that. Okay. The rest you read. Okay, the rest you read. Important, this one you rarely touch because they are stable. The confusing part is here. When it's reached 3 to 4, you see the energy axis? Energy axis means you want to jump energy from here to here, you need to release energy. Or the energy jump from here to here, you give the amount of energy here, it will jump from here to here. But what happens if it's 3 and 4? You see number 4, your S, the orbit number 4, your subcell, the energy is a bit lower than D in orbit number 3. So if you give energy from 2 here, if your electron is at here, you give energy that is lower than D, it will jump to orbit number 4 before it go into 3. Can you imagine the electron? Like for example, this is the energy you give. Let's say you cannot give until this range. Let's say here is 10. You give 9, let's say. So it's not reach 10, you only have 9. So when you give 9 here, the electron can only like jump from here to here. It cannot reach here. But the energy to reach here is at orbit number 4. So it will like jump a bit it will be in the lane number highway number 4 and not highway number 3 because of the energy level. So because conventional, our thinking is that if you add energy, it will jump from N1, N2, N3, N4. But since we learn about the subcell and everything, so there is a possibility if you give a certain energy, the electron won't stay in orbit number 3, but it will jump to orbit number 4. It will skip the highway and then go into highway number 4. From highway number 2, jump to highway number 4. If you give a certain energy to 4, or it will jump from 3, it will jump to 3, it will jump to highway number 3S, change lane. You give more energy, it will change to highway number 4. Then you give more, it will change lane to highway number 3, but the maximum, the outside lane of number 3. Then you give a little bit more energy, it will jump to lane number 4, highway number 4, lane number 2. Make sense, huh? It will like, it depends on the energy level, it will like switch highway and switch lane, depending on the energy level. It's not like conventional thinking like, okay, you add energy, then it will keep jumping. No, it can change from highway to highway, lane to lane. So this one, as you do more exercise, you know how to differentiate, especially if you do more n numbers. Confusing part is after lane number 3. After n equal 3, then you'll start to confuse already. Because the lowest orbit that need energy, you will reach that first. For example, this 3, you will reach SP, then you will jump to number 4, S, then you jump back to 3, then jump back to P. Yes, then this one, number 4, right? So you add energy, it will go to highway number 5, S, back to D, number 4, then you go to 5. Then you go, you have energy, then this one almost same. So it might be jumping from highway 4, 5, these 2 lanes. The electron will jump from here. Okay. So you know that 1, 2, 3, 4. If you recall the the chemistry class. Chemistry class. This side is 1 electron, 2 electron, and then this side is like 6 and 7, right? So if you have 4 here, you see all the confusing part is here. You see the intermediate here is 4 to 6, about there. 3 to 6, this one. Where the electron is not very clearly defined because of the energy suborbital here. It will jump here and there. That's why they put in the middle of the periodic table. And that's why they design in such a way. Okay, so with this, we stop here. The rest you read from my slides. Okay. This one also calculation. Maximum number of electron of each shell, 2n squared. Okay, so this table also help you to predict the number of electron. Just now, the equation that I write on the whiteboard here is orbital calculation. This 2n square is the number of electron for that element. But this one we will come back in our next lecture this afternoon. Okay, stop here.